Okay, this week we're going to continue doing linear regression. So don't forget the concepts you learned last week. We're still going to want to do scatter plots and look at residuals and our correlation and coefficient and critical values to see if there is a relationship. But we're going to learn a couple other tricks this week to kind of see if there is a correlation. So let's first start out with running the regression. So if we click on the blue box, click on a little blue box, we can either open it in StatCrunch or in Excel. Some of you I've noticed have been using Excel for the discussions. That's good. I prefer Excel because that's what if you do any of this in the real world, you'll probably use Excel. But for a majority of you are using StatCrunch, so I will do the video in StatCrunch. We can still do our scatter plot here under graph if we want to. Or, as you know by now, if we go to regression, simple linear, we click our X variable, click our Y variable. Remember, our X is our independent or our explanatory variable or predictor variable, and Y is our response variable. This is the new stuff for this week. So hypothesis test. We can do a hypothesis on the intercept, which really doesn't tell us a lot, or we can do a hypothesis test on the slope, which does tell us a lot. If you think of a line, the slope is how much it changes. It either increases or decreases. So if we have any kind of a slope other than zero, there is a change in our line. It is either increasing or decreasing. If our slope is zero, that means we have a flat line. There is no relationship there. And if there's no relationship, then there's no correlation. So our hypothesis test is always on the slope. So our slope equals 0, and our alternative is our slope does not equal 0. Because if we don't have a slope of 0, then we have a relationship. So in this case, typically we're going to want really, really small p-values to show that we have a relationship, that the line does change. All right, we can also build confidence intervals if we want to. This problem we will later on. So we'll have to rerun our regression as always because you can only do either a hypothesis test or a confidence interval. We can do predictions. So first we'll start with a fitted line plot. And we'll compute. Make this big. So as before, our dependent variable is our y, which in this case is cholesterol. Our independent is our age, our x. Here is our regression line. Here's our sample size n. Here's our correlation of coefficient. It's just kind of really low, so we can compare it to critical vehicle like we have in weeks past. Here's our standard error. So this is how much error is in our line, which basically is the difference in our predicted line versus the actual data. Here's our slope. Our intercept value, which is the same as up here, and then our slope value, which is up here. And then this is all the formulas, and then here's our p-value, right? So if we look at our scatter plot, we kind of see that our line goes down, but our data points really don't. They seem to just be kind of random. I don't really see, so there's not a linear relationship, and because I don't really see any pattern anywhere, I want to say there's no relationship here, so there does not appear to be a relationship in this case. If there would have been a relationship other than linear, you would have seen a pattern. Either the points would have been clustered, or they would have gone up then down, maybe like an S. So since this is just like this, there is no pattern. I would say there's no relationship. But we can have other relationships other than linear. In this class, all we learn is linear, though. All right, now we need my line, so let me go back and move our stuff around because we actually can see my values here, so I can type them in. Be careful with your decimal count, right? That is a thing with our math lab. It says 3 decimal places, so I gotta make sure I input my values at 3 decimal places. So it wants our slope first, which is here. So negative 0.156, 3 decimal places. And then our intercept, 51.543. I have to round up because the 2 and 9. My answer. Okay. Are there any outliers? Well, let's go back to our scatter plot. We come back to our scatter plot. They are spread out, but they seem to stay consistent. This guy's a little low, and this guy's a little high, but I would say there's no outliers. They would be really far from the data. So are there any outliers or influence? I say no. So remember, we can do, go back to our analysis so you can see it. We can do a hypothesis test on the intercept, and we can do one on the slope. But the slope is what tells us stuff, right? That tells us if there is a change. So we want B1. And our alternative, our null is always equal, so all B and C are. And then for alternative, we don't really care if our slope is increasing or decreasing. We just want to know if there's a relationship. So we're always going to pick the not equal one. And how can we tell if it's increasing or decreasing? Well, we just look at the sign in front of the slope. This line is negative, so therefore it is decreasing. So that's why I don't need to do a less than or greater than, because I can just look at the sign. All right. P-value. Again, we want the p-value from the slope. So we come over here. My p-value is 4332. They want 3 decimal places. 0.433. So the good news, hypothesis testing. Nothing has changed. We're going to keep doing what we've been doing. So if our p-value is less than our alpha, our level of significance, we will reject. If it is larger, therefore we do not reject. So we really, in regression, we want small p-values because we want to reject. Because remember, if we reject, that means we have a relationship. If we do not reject, that means our slope is basically 0, and therefore we do not reject. So in this case, 433 is definitely way bigger than 0.01. So 43% versus 1%. So I'm definitely going to do not reject because my p-value is greater than my level of significance. Therefore, there is no relationship here. And therefore, I can't use my regression line. All right, now I want to build a confidence interval. And because of the limitations of this software, I have to rerun the analysis. So my stat, regression, simple linear regression. Make sure you check what kind of confidence interval you want to build. In this case, we're 95%. If it's something other than, make sure you change it. Let's kind of save our residuals here, because I want to show you how to use your residuals. Where they are, residuals, and then hit compute. And you notice when I do that, it creates my residuals. Remember, my residual is the difference between my predicted value, my actual value, my y here, and what happens if I take 56 and put it into the equation. This is the result I get, and that's the difference. Oh no, and take that result and subtract it. That's the difference. So, we got that. Now, make this big because we'll come back to residuals in a minute. Here is our slope. Right? Now you notice that the hypothesis test stuff's gone, but it's been replaced with a confidence interval. So again, we want it of our slope, so we make sure you put the right values in. Again, 3 decimal places, so negative 0.557. It's 0, you can put it in or not, it's not going to call it wrong either way. 0.2575. Not too many decimals, so it has to become 0.258. And notice on our confidence interval we get the same results because we have our lower bound is negative, our upper bound is positive. That means 0 is a possible answer for our slope. Therefore, we reject it just like as we did before. All right, what are we doing? For 40, if the null hypothesis was rejected, this means that the least square line. But all right, so this is reminding us that depending on if we reject or reject, can we use our line? In this case, we did not reject, so therefore we cannot use our line. A nice little friendly reminder before you answer this question. So, should the least squares regression line be chosen? No, because the hypothesis was not rejected. Because we have a slope of 0, there's no relationship, so our prediction is not going to help us solve the problem. All right, now it wants a good estimate, so I'll come back here, go back to my results. Oh, that's my graph. Oh, it's right, I blew it up. Go back to my results here. Well, I can't use my regression, so I'm going to close that. If you ever accidentally close it, you notice my results are still here. I can go back. There's my one for hypothesis test. Here's the one for my confidence interval. So how do we make a prediction if we can't use our rejection line? Well, we have to find the mean of our y values here. So how do we do that? Just like we did way back in week 1, which seems forever ago. Click on Stat, Summary Stats. We're going to do column. We want the cholesterol, and I can just click Compute. And then I want the mean, right? The average of the cholesterol column is the best prediction when we cannot use our regression line. So it wants 2 decimal places, so it looks 44.59. 44.5. Helps if I type into box. Nice. So that question is done. Let's go to, we'll go to question 11. I'm going to close this. Now, the reason I put my residuals in here, because we want to, remember how we want to look at residual plots? So I have my residuals. I can actually do a scatter plot of my residual against my x, or my residuals, and I can click Compute. And there's my residual plot for age x versus residuals. I can also do y. There is some residual plots pre-built into the regression analysis. Some work well, some don't. So that's why I like to also do it this way, so I can control. I don't have to let the software pick the type of scatter plot I want. I can pick it myself, and I can do it. Remember, when we look at residuals, no pattern. We have no pattern here. That's good. A consistent variability, and it doesn't change over time. In reality, the way I always like to look at my scatter plot, if anyone's ever shot a shotgun, bird shot at a paper target, you see it makes a bunch of holes and it's random. That's how your scatter plot should look for your residuals. If your scatter plot looks like a shotgun blast and there's no real pattern, it's just kind of all over the place, then that is good. So this is a good residual plot. But again, just because we have a good residual plot doesn't mean we can use our regression line if our regression line is no good, and vice versa. Just because our regression line is good, if our residual plot is not good, then we still cannot use our regression line. All right, I'm going to close out StatCrunch, because if I don't, I'm going to get this error about pop-ups. All right, now we also this week learned multiple regression. So when you're doing multiple regression, you can have more than one x variable. You can have one more explanatory variable to go with your response or predictor variable. Right? So we only can have one y, but we can have multiple x's. This one, you can see I've already done it. That's why I want to show you how to do residuals, because there's questions about residuals on the multiple regression. But all I want to do quickly here is show you how to do a multiple regression in StatCrunch. So I click on my data, open in StatCrunch, or in Excel. Excel can do multiple regression as well if you have data analysis installed on your Excel. And then I go to Stat, go back to regression. Instead of picking simple linear, we are going to pick multilinear. And you can see there is other types of regressions. In our class, we only learned these two, though. If this is something that does interest you, I highly encourage you to take other statistics classes. So, only one variable. Only one y variable, so it's y. But we have multiple x's, so I add both of them. Interactions, that's something we will learn in more advanced statistics class. For us, just leave it blank. Again, you can notice we can do hypothesis tests, we can build confidence in it. Everything we could do before, we can still do. We can't plot it, a scatter plot, because now that we have two x's, we're actually graphing in 3 dimensions. And if you have more than 2 x's, you have 3 x's, that's 4 dimensions. So it gets a little challenging, but you can have your residuals. So I would definitely click residuals, so you can build these plots that I have below, and then click Compute. And you notice there's my residual plot. So then you can go through and actually build your scatter plots to answer the questions, because the ones that regression builds is not going to help you answer the questions that they want you to do, because they want you to build one for each of the x's. So now you notice I have an intercept. I have x1 and I have x2. So I got to check both of these hypotheses, and so you got really small p-values. So there is, even though we cannot see it, a relationship between these variables, which are air temperature, wind speed, and get prediction of wind chill. If you think about that in life, right? If it's cold out, even without wind, just a little wind, it's cold, the wind chill's low. or if it's not too cold but you have extreme wind, then the wind chill is cold. So these variables should have a relationship with wind chill, and we can see statistically they do. They have very small p-values, so there is a relationship there. Here's our equation. So I just retyped it right here into the thing, and then build your residual plots. I'll let you guys build your own this time, but the key is just make sure when you do your multiple regression that you highlight your residuals, then you can do a scatter plot. So this first one wanted, let's draw a residual plot of air temperature, so I'll use x1 and these residuals. And then do another scatter plot for the second one and compare. And remember, we're just looking to see if there's a pattern or not. Keep up the good work. We have this week and one more week as our final week. I know next week's going to be really, really busy. So if you are behind, I highly encourage you to catch up. We have a discussion for our final week. We have a homework for our final week. And we have a final. So a lot to do in that final week. It can be overwhelming. So if you are behind, please catch up on everything. I will adjust grades as I see you are catching up. Good luck. This week's just regression, so not a lot of new concepts, so it's not too bad. Next week is a new concept, ANOVA, and we'll talk about that soon. Have a very wonderful week. Talk to you later.